Hello everyone. This is a linear regression problem, and it's pretty much gonna cover our chapters 13, right? So this is the first question on 13 EOC, right? Okay, so the problem itself is talking about predicting the net receipt for the first week in thousands of dollars. All right, so this is what you are predicting, and that you're going to predict it out of the critics, right? Tomatometer critics, right? Okay, so what we're going to do is we're going to consider the rating or the Tomatometer's rating as an X variable, and then we're going to predict the Y variable. All right, of course, we have a table here. This is prediction of some movies, and from there we're going to predict the first week or the first weekend of each movie accordingly with the critics. All right, so now this problem is kind of long. I decided to cut it in 3 pieces, and this is an example, as you can see here. So the first one, I'm going to use the hypothesis testing, whether the model is good or not, and show you the different steps. And we're going to go over all these questions. So we're going to cover up to question G. All right, so question G. Later on, I'm going to add 2 more videos covering H by itself. I'm going to construct the confidence interval. All right, so that's going to be 1 video itself, and the third video is going to be construct the prediction video. Or the confidence interval, you're going to be using this formula. As you can see here, we can try to identify other variables and plug them in, and the predictive interval has a different formula, slightly different. So there is a 1 here that is extra in the formula, but pretty much it's the same thing. All right, so let's get into it. Okay, so I generated new questions. So the value that you're gonna see on that we're gonna get here, they might be different from the previous values. First of all, you can download the table from here into Excel. I got it already. So this is my table, and we want to identify the B0 and B1 basically, right? Here there are 2 ways to do it. Now the first method consists of graphing it. So I can go insert and then go to scatter plot. So this is scatter plot, and I'm going to put, this is wrong, so, but I'm going to clean it. So right click, you go to the menu, you select the data, and then delete those series over here, right? So remove them. And so the name of the series is going to be, I can click on movies, that's the name, and the X values, I'm going to select only the values here. So this is going to be the Tomatometer rating, and then the Y values, you always take away the value 1 there, right? And you select the corresponding Y values, which is the receipts in thousands of dollars. And that's basically it. You close it, and this is scatter plot. Now, how can I get the equation? Click on one of the dots here. Once you select all of them, right click again and add a trend line. And this, you're gonna draw the least square line, and you're gonna click on these last 2 boxes, display the equation of the chart, and display the R squared. And there you go. You don't need any more this table. Here you can select this, and you increase the size you want. Okay, that's basically the 2 variables. So this is enough actually to answer most of the questions. All right, or at least part of them. You get here, this is the value of B1, so 0.2546, and this is the value of B0, which is 1.2768. All right, so let's put this aside. And now is the second method. So the second method, you're going to be using the data table and data analysis. And then you're going to go to regression, select regression, say OK, and then you select the Y values. So the Y values, I'm going to select the header as well, the receipts instead. And I'm going to select the same thing for the X's. So be careful here, the X and the Y, they are flipped. So the X's is the Tomatometer rating. And don't forget to click on the label here. That's basically it. The outcome, you're going to be select a cell. And well, here we're going to add a residual plot because they're going to ask us about it later on. So residual plot should be okay. All right. And that's it. Okay. All right. So what is a residual plot, by the way? So residual plot is basically graphing the line, the distance between every point, the vertical distances, right? The point and the line. So this is the first one here is almost on the line. Second one is far away, this distance. This should be the third one, closer to the line. There you go. This is this two, the distance from here to here. So you see is negative, and over there, and so forth, right? So this is a vertical distance, all right, with a different scale, obviously, right? Okay, so we know what this means, the residual plot. And there is a question that you're going to be asked about residual plot. That's why we are added here. Now, what we want from this table, you want always to identify the R squared. That's going to be part of the question. The standard error, all right, number of observation. As well, here they are the coefficient. This is B0 and this is B1, all right? So you can add them here. This is B0 and this is B1. Now, two more things that you need, the T statistic. T statistic only for the B1. B0 is irrelevant. So the T statistic, this one value here, and the P value, this one here. Okay. All right. So let's try to get into the problem. All right. All right. So the first one is to identify B0, which is this value here. I'm going to copy it, paste it, and round it to 2 decimal places. So that's going to be, instead of 27, 28. The same thing I'm going to do for B1, copy it, paste it, and you want 4 decimal places there. So let's see, 25, 46. Check. Good. All right. So now they are asking you about B0, whether is appropriate to make interpretation or not. So what does mean B0? B0 is when the X value is 0. It means the rating of the movie, it was a 0, so it has a 0 rating. And the reason we don't take it, is not appropriate to take it, because whenever we look at the table here, you see the values of tomato rating is the lowest value is 15. So there is no 0. So it means our model does not cover the 0. All right. It goes only from 0 all the way to 93. So that's the highest value. I cannot even predict 100% rating. All right. So the only prediction I can make is between 15 and 93. All right. So I hope this is clear. So definitely is not appropriate, and the reason, because the movie cannot be, not this one, because this one here, the appropriate interpretation for B0 because it's outside of the range observer tomato meter rating. So this would be D. All right. Now B1, what the meaning of B1? B1 is the slope again. So the slope of this line, it means for every 1 unit, you go 1 unit here, the M would be the rise. All right, so this is B1. So for every 1 unit in rating, that's the value of increase, additional income or additional receipts. All right, so here the value B1 indicate for additional $1 receipt. Nope. It is appropriate B1 because outside the range. No. This one should be D. All right, the value of B1 indicate that for each increase of 1 unit in tomato meter rating, predict receipt are estimated an increase by a value equal to B1, of course, in thousands of dollars, right? So that's going to be the good one. Now, he's asking you to make a prediction for 55. I'm going to do it 2 ways here. So the first, what you need these 2 values. So I'm going to copy them. So this is the values of B1 and all right. So now the 2 ways you can do it. You can use a matrix or you can use equation of a line, right? So if I want to use the matrices, I need to do 1 here and 5. So this is 55, sorry. So that's the value of X. 1 is going to be by default. And here you're going to use equal sign and multiplication of matrices. So MM multiplication, that one, MMULT. And then you have to select this one first, right? So it has to be 1 and 55 horizontally, and then comma, and then you select these 2 and enter. So that's going to be 12.726. The second method. So what I'm going to do is, let me copy this again. And this is the value 55 for me. So I'm going to use equation of a line, right? So I'm going to create a function that basically a calculator here. So this is going to be equal sign. I start with B0, which is this one, and then plus I click on the M, which is, I'm going to drag it to the other side right now. There you go. And then multiply it by 55. And that's it. So that's going to be the same thing, right? Again, what I did here, there you go. You can see it better. So I took the B0, which is minus 1.2768, plus the M, click on the M, which is 0.2545, and then multiply it by the value 55. All right, so just plug it into the equation. Y equals mx plus b, right? Okay, so let's get this value. Paste it here, and you want to round to 2 decimal places. So that's going to be 73. Okay, great. Now, again, this is very similar question to the y-intercept, whether it's appropriate to make interpretation or not. It's giving you 5% rating in Tomatometer rating, right? So this is again is with the values, right? So it's below the minimum value, so it's not acceptable, below than 15, so we cannot predict it. We could predict 55 because 55 is between 15 and 93. That's fine. So we did the work. However, for 5%, is not within our range. So the model should not be used because 5% is outside of the range. So it should be B. Okay, so now we are looking for R squared. So R squared is right here. We talked about it earlier. So this is R squared. Now, what the meaning of R squared? All right. So R squared, it gives us the precision of the model. All right. So basically the receipts here, or the dollar amount, all right, is 53.97% or 0.5397. All right. So this is the amount of money, which is the Y value. All right, is depending here on the value of the rating on the X value, and this is the X value. So it gives you the proportion of the variation of the Y value from the X value. All right. So we know that the rating does not generate 100% of the income. So the rating is only opinion how good the movie is. All right. And depending on the rating, people, they don't take it in consideration like 100% whether they're gonna visit the movie or not. All right. So only 53% or 54% of the people who are the moviegoers will take in consideration the rating. All right, whether they're gonna visit or not. Okay, so here, all right, should be B. So the coefficient of determination R squared, which is this one, this is the value proportion of the variation of receipt, that the Y value, that is explained by the variation in Tomatometer rating, and that should be the answer. Okay, great. Okay, so this is the question that we were talking about, that we might need this graph. So the residual plot, and here we're gonna express what we see on the residual plot. So the residual plot shows, obviously there is no pattern there, right? No linear pattern, no pattern at all. And because the residual here are scattered randomly, so that's what you should choose. And residual plot shows clearly unequal spread. All right. And this is definitely not necessarily a cyclical, and definitely not necessarily a normal probability plot. That suggests that residuals are roughly normal distributed. All right, normally distributed. And that's basically it. Okay, so that's why we need a residual plot. Okay, now we are using the null hypothesis. The null hypothesis is always the same. So beta 1 equals 0 or beta 1 different than 0. So this you're going to select beta 1. So that's the slope value. So either you're going to be equals to 0, and that's going to be the null hypothesis. And beta 1 for the alternative, you're going to be different than 0. And that's going to be the alternative hypothesis. Okay, the t statistic right now, we can get it from the table. So t statistic for B1 again. So let's get it. It's 2.4. You need to round it to 2 decimal places, so 2.42. Now the p-value is just next to it, right here. and that's going to be 0.06. Oh, 3 decimal places, so you need another 0 there. Excellent. Now, whether we're gonna accept or reject, let's see what's going on. So now I don't have the critical value, all right? So it's fine. However, this value over here and this value over here, I know in total it can be 0.05. Why? Because they are giving us 0.1. So this is the value here. So the level of significance is 10, 0.10. So what does mean for me? It means that this one, where the alpha is going to be 0.10. So this value is going to be the alpha over 2, which is 0.05. All right, add another 0. Now, that's the value of the alpha over 2. So that means that the critical value is, this is the area of the critical value, right? Now, all right, so here the p-value is 0.06, right? So now, if I graph the p-value as well, I need to graph only the half of it. So the half of it is going to be right here. I'm graphing it on top of the alpha value purposely because I need to know whether you're going to fall within or outside the rejection zone. And this is half of the p-value because I have the other half, like the alpha value, half here and half there. This is a two-tailed distribution. All right. So now I'm using the graph here in order to illustrate the purpose. So if the statistical value is here, this is the stat value, and this is the critical value. All right. So once the statistical value is outside of the, or after the critical value, we reject. So this is the rejection zone. This is the threshold. Critical value is reject, 80, right? And reject here, 80. So what we did, we just rejected this one and we say this one is good. All right. So we keep the H1, which is beta 1 difference 0. So is it a good thing for us or not? Yes, it is a good thing. Why? Because whenever we do the linear regression, we need the B1 to be different than 0. Otherwise, there is no slope. Whenever there is no slope, no correlation, and the model is really bad. All right. So to make this story short, all right, so what we need to do, just compare the p-value and the alpha value. All right, you don't need to do the alpha over 2 and the p over 2. So if the alpha value is greater, then you reject 80. And that's what we are looking for, right? So this is the conclusion we want to end up every time, all right, in order to get linear regression, all right? So for this scenario, we have to reject 80. And do we have sufficient evidence? Yeah, we do. That's the p-value. P-value is smaller. That's the evidence. Every time you reject, there is sufficient evidence. Every time you go with the H1, you have evidence. All right. Okay. Done. All right. So I'm going to stop here and get back with the construction of the confidence interval.